Hello everyone, I am going to explain question number first C and D part of exercise 7.6 from class 12. So you can see that question number C, we have to prove the Rolle's theorem for the function fx is equal to mod x. So students, I suggest that before doing all these questions, you just go through with the theory of your book, which is given at just before 7.6 exercise. In that it is clearly mentioned that which functions are continuous and which functions are differentiable in the interval. So go through with that, then you can write down the statements very easily. So here we have the modulus function, and as you know that the modulus function is continuous for all the real number, that's why we are going to write here that f mod x is continuous function, and so it's a continuous function, that's why fx is continuous in the closed interval. But we know that the modulus function is not differentiable at 0, and 0 belongs in the open interval, and that's why fx given function is not differentiable in the open interval. So the second condition of Rolle's theorem is not satisfying here, that's why Rolle's theorem is not applicable for the given function in interval -1 to 1. So these information we wrote because we already knew that the modulus function is continuous, but modulus function is not differentiable at 0. Now we are going to start the D part of the same question. In D part we have the polynomial function, and we all know that the polynomial function is continuous as well as differentiable for every real number. That's why fx is continuous in the closed interval, the interval which is mentioned in the question, and fx is derivable, or you can write here differentiable in the open interval. So two conditions satisfied. Now we are moving to the third condition, that is functions value at the lower limit and functions value at the upper limit. So you can see that the functions value at lower limit is 0 and upper limit's value is also 0. So we found that the functions value at lower limit as well as upper limit is same. So all three conditions satisfied. Since all three conditions is satisfied, that's why we are moving further. We are going to find out the f dash x, means you have to differentiate the function with respect to x, which will give us 2x plus 2. And that's why, since it is f dash x, that's why f dash c is going to be, instead of x, replace it by c. We will obtain this. Now since previously already we mentioned the three conditions of Rolle's theorem satisfied, that's why it implies that Rolle's theorem says that if the conditions of Rolle's theorem satisfying, then f dash c is equal to 0. So we are going to keep this equal to 0. That will give us the value of c is -1, and this -1 belongs to the open interval -4 to 2. That's why Rolle's theorem is satisfied. So question number first C and D part completes here, and here students, the main concept is we should know that which functions are continuous and which functions are differentiable in the given interval. So to learn that, you just go through with the theory which is mentioned before exercise 7.6, and I suggest learn that given functions are differentiable or continuous. Thank you.